So today I am going to discuss with you the transmural pressure, the left out topic of the last topic. Now, transmural pressure. Now, what is transmural pressure? Transmural pressure by definition is the alveolar pressure minus the pleural pressure or intrapleural pressure, or the pressure between the parietal pleura and the visceral pleura. Okay, now transmural pressure. Why we need to study this transmural pressure? Because transmural pressure is the pressure which keeps the lung open, because I told previously that lung has tendency to collapse, so it will collapse if there is no pressure. There is nothing to save the lung to collapse. So our transmural pressure will help lung to be little bit inflamed, because I told friends during expiration also the perfusion is there. Perfusion is there. That's why we need little bit of amount of air in the lung while expiration also. Okay, so this transmural pressure. Now, how to calculate transmural pressure? Nothing, simple formula. Alveolar pressure during inspiration. Okay, alveolar pressure during inspiration is 0 minus pulse pressure, or no, sorry, pulse, not pulse pressure. Pleural pressure during inspiration is minus 8, which comes plus 8, and this transmural pressure is calculated in centimeter of water. Okay, and now expiration, during expiration alveolar pressure is again 0, but the pleural pressure is minus 5, which comes plus 5. So friends, I told you it has to be in positive. It should be in positive so that the lungs doesn't collapses. Plus 8 plus 5. It is in plus during inspiration, during expiration. So remember these values. Okay. Now, moving forward, friends, I will try to teach you very fast and clear the concepts as well. Now, work respiratory muscles. So, when the respiratory muscles are active, if someone asks you when the respiratory muscles are active, simple, during inspiration, respiratory muscles are active. Okay. Now, I will tell you the concept of compliance and elasticity. Very important, friends, because this concept only will help you to understand the restrictive pulmonary diseases and the obstructive pulmonary diseases. Okay. So, what is elasticity and what is compliance? What is the difference? Now see, elasticity, when someone tells you about the elasticity, everyone thinks that yeah, elasticity means elasticity. This is the elasticity. But friends, no, it is not the elasticity. Elasticity of a substance, of a material, is known by when the material is stretched and when the material again comes into its original position or original shape and size. That is called elasticity. So when I am stretching a rubber, that is not elasticity. But when I stretch the rubber and leave the rubber, if the rubber comes in its own original shape and size, that is the elasticity. Now what is compliance? Now when I am stretching, that is compliance. How much I can stretch, that is the compliance. Okay. So elasticity is the how much a material will regain its original shape and size, that is elasticity, and how much a material is stretched or can be stretched is called the compliance. Okay. Now there are two types of diseases: restrictive type of diseases and obstructive type of diseases. Okay. So restrictive type of diseases and obstructive type of diseases when we talk about the lungs. Okay. So restrictive type of diseases, what happens? In restrictive type of diseases, there is decrease in compliance. Okay. You cannot inflame the lung as much as you can. Okay. Means you cannot take air in. If I am a patient suffering from restrictive pulmonary disease, for example, silicosis, asbestosis, all are restrictive pulmonary diseases. If I am suffering from that disease, restrictive diseases, I cannot take air inside my lung. Inspiration is default, is disturbed. I cannot take like this. Okay, so compliance. In restrictive diseases, compliance is abnormal. Okay friends, compliance is abnormal. So now think yourself only, friends, what will be the best way to breathe for a patient suffering from restrictive disease? Tell me. He or she, the patient, is not able to inspire air properly. Okay, if the patient starts getting air slowly, will it be helpful? Of course not, because inspired air is not going to help. Restrictive patient has to breathe air very rapidly. Like this, rapid and shallow, rapid and shallow. If you see a patient breathing like this, it is having restrictive pulmonary disease. Or the best or the suitable way of breathing for a restrictive pulmonary disease is slow and shallow. Okay, this is okay friends. So when you talk about the obstructive, to the opposite obstructive, here the compliance of a lung is very much, or I can say very much increased. So you can take the air very easily in, how much you want. The problem is in taking the air out. So the person, the restrictive diseases, you take the breathing like rapid and shallow. Now the opposite, in obstructive diseases, you take slow breathing and deep, because the problem is in taking out air, not taking in air in obstructive. Simple. Obstructive type of diseases. Okay friends, obstructive type of diseases comes emphysema, bronchial asthma, all those diseases. Okay, now this was the concept of COPD and restrictive pulmonary diseases. Now we will discuss the concept of the compliance once again. So what was the compliance? Compliance was the stretchability. Okay, and elasticity was the material will come into its original shape and size. That will be the elasticity. Okay, now there are some diseases in which compliance decreases. Compliance, stretchability of the lung decreases, goes down. For say example, you take about pulmonary interstitial fibrosis. In this disease, the compliant lung is not compliant anymore. Okay, and there are some diseases which increases the compliance. Okay, which increases the compliance, and that is COPD. Which best example is emphysema. The compliance of the lung is so much increased, it is very simple or easy to take air in, but very tough and hard to take out the air from the lungs. Okay, now when you talk about the compliance and all these things, you cannot move forward further before talking about the surfactant. Now friends, this is most important topic in lung. If you don't know anything up till now, doesn't matter, you have to know this. Surfactant. What surfactant do? Surfactant is the substance which keeps our alveoli open, doesn't help or doesn't closes the alveoli, doesn't collapses the lung. Indeed, Okay, so surfactant helps to open or not to close the alveoli. Okay, so major surfactant is the dipalmotyl sulfadyl choline, or another name dipalmotyl lecithin. Okay, this is the common or most important surfactant in the lung. What surfactant do? It reduces, it do three things. It reduces the surface tension first. So it do three things. Okay, first it reduces the surface tension in the lung. Okay, second thing it do is it reduces the tendency of alveolar interstitial fluid to transudate out in the alveolar space, because there are capillaries here and there in the alveoli. It doesn't allow the liquid to pass from that capillaries to enter into the alveoli, so that again fluid will come. It will be problem in breathing. Okay, so this is the thing. And the third function which surfactant do is it reduces the natural tendency of a smaller alveoli to collapse and empty into larger ones, and this process is called the alveolar stabilization. Means, for say example, if the small alveoli is there, it is saying it reduces the natural tendency of the smaller alveoli to collapse and empty into the larger ones, because sometimes larger ones could collapse but the smaller one should have work because breathing is going on. So the larger alveoli, smaller alveoli, surface tension, the surfactant is present, it reduces the collapse of that smaller alveoli, so that the large alveoli should not close, because large alveoli will be made up of small alveoli only. So there is tendency, I told you, there is a natural tendency of a lung to collapse. All these features, all these substances, surfactant, transmural pressure, all this helps not to collapse. Their function is not to collapse, so that lung should not collapse. Okay, and our breathing goes on. Okay, now surfactant. When we talk about physiology, now there are some diseases. Surfactant deficiency is present. Surfactant deficiency is present mainly in smokers. Okay, smokers. Why? Because in smokers there is, when a person smokes, the person has in lung alpha 1 antitrypsin. This is an enzyme used in surfactant process, and alpha 1 antitrypsin enzyme reduces the surfactant production. Okay, so in smokers there is decreased surfactant production. Okay, friends, surfactant is produced by which type of cells in the lungs? Surfactant is produced by type 2 pneumocytes in the lungs, which are present in alveolar epithelium. Okay, so now this is one thing. Alpha 1 antitrypsin deficiency in smokers leads to surfactant decrease. Now another inherited disease, or I can say, if a woman is pregnant and he is giving birth to a baby which is preterm means 35-36 weeks. Okay, so that baby will have immature lungs because of decrease or reduced amount of surfactant in baby's lung. So if a baby or if a mother is giving labor, preterm labor is present in a lady, that will lead to respiratory distress syndrome. Respiratory distress syndrome, or I can say hyaline membrane disease. This is the respiratory distress syndrome, also called hyaline membrane disease or disorder, which results in decreased level of surfactant in the lungs, and because of that, respiratory distress syndrome. So the preterm mother who are giving birth, we give them glucocorticoids because glucocorticoids increases the production of surfactant in the babies. Okay, friends? So this is the thing. I will be teaching all the airway resistance in the next lecture. Thank you.